Hi children, देखो यहाँ पर once again an extra sum from standard 9th. X is midpoint of BC. X is midpoint of BC, and they have given X XZ is parallel to AB. Segment XZ is parallel to AB, and segment YZ is parallel to AX. In triangle ABC, we have X midpoint. X is midpoint. X is midpoint of BC. Therefore, I marked this something. And then they have mentioned this XZ. XZ is parallel to this blue segments. Can you see? XZ is parallel to AB, and YZ is parallel to AX. We are supposed to prove YC, this small piece. Can you see a YC? YC is 1/4 of BC. YC is 1/4 of BC. Okay. So how are we supposed to attack this particular thing? First, we shall consider this big triangle. ABC. Can you see? There are multiple triangles in it. Please focus on ABC. In triangle ABC, X is midpoint of BC. This is given. Okay. Now, I'll take this blue line and AB. They are parallel. So it is Seg AB is parallel to Seg XZ. This is given. Can you see this? So do you recollect something, which theorem we can apply? It is converse of midpoint theorem. Which one? Converse of midpoint theorem. So if a line is parallel and bisects the first side, it will bisect the second side also. So what will happen is that, therefore, Z is midpoint of AC. This is by converse of midpoint here. Okay. So since Z is a midpoint of AC, can I mark this segment is congruent to this? So it is, that is, AZ will be equal to ZC. Okay. Now, let's come to triangle AXC. Only concentrate on this triangle AXC. Point number 2. In triangle AXC, Z midpoint of Seg AC. We have just proved it here in statement number 1. Next, second part of given. It's given that YZ is parallel to AX. Seg YZ is parallel to Seg AX. This is given. So children, can I apply the same theorem what I've applied in statement number 1? Because in triangle AXC, Z is midpoint of AC and YZ is parallel to AX. So Y should be midpoint of CX. Therefore, Y is midpoint of CX. Reason again, converse of midpoint theorem. Okay, so I got y is midpoint of seg Cx. This can be written in other way around. I can write therefore yc is equal to half of Cx. That is nothing but yc is half of Cx because y is midpoint of Cx. Now, in given, they had mentioned x is midpoint of BC. If x is midpoint of BC, then Cx should be half of BC. So I'll write here point number 3. Cx is half of BC. This was because x is midpoint of BC given. Okay, children? Now what I can do is that, see here Cx is there. Here also Cx is there. In place of Cx, can I substitute this? I'll remove Cx and in place of Cx, I'll substitute the value. So point number 4 gives me yc. Therefore, yc is equal to, half is there. First write that half. Then put bracket. The value of Cx is half of BC. So it is half of BC. This I am getting. I am substituting 3's value in statement number 2. So it is 3, 2. Now if I open the bracket, I'll get yc is equal to 1 upon 2 into 1 upon 2 is 1 upon 4 BC. So you have to be very careful. Here, Cx value is half of BC. So in this equation, yc is equal to half Cx. In place of Cx, I am substituting the value of Cx, that is half BC. Hence, yc will be half, then bracket value of Cx, half of BC. So half into half, it gives me 1 upon 4 BC. That is what I have to prove. Thank you.